Hi there. This is a realistic DevOps interview simulation focused on capacity planning when you do not have perfect information. No clean traffic curves, no stable growth assumptions, just uncertainty, pressure, and real production risk. I want you to treat this like a real interview. Pause the video after each question. Say your answer out loud. Then listen to how a strong candidate might reason through it. If this is useful, subscribe so you do not miss the next interview in this series. Warm-up behavioral questions. Let us start with something simple but revealing. Tell me about a time you had to make an infrastructure decision without having all the data you wanted. A strong answer here usually starts by acknowledging the uncertainty instead of hiding it. For example, I might say that I was supporting a system with rapidly growing traffic, but historical metrics were incomplete because observability had only recently been added. Instead of waiting for perfect data, I identified the biggest risks, such as CPU saturation and database connections, and added conservative buffers around those. I communicated clearly to stakeholders what assumptions I was making and what signals would tell us if we were wrong. That way, the decision was reversible and everyone understood the trade-offs. Next question. How do you balance cost concerns with reliability when planning capacity? A strong candidate does not jump straight to numbers. They usually talk about priorities. For instance, I might explain that I first classify workloads by business criticality. User-facing paths and revenue-generating systems get more headroom. Internal or batch systems get tighter limits. I try to avoid over-provisioning everywhere and instead invest in fast scaling and clear alerts. The goal is not to minimize cost or maximize reliability in isolation, but to align spend with actual business risk. Another one. Tell me about a time when your capacity plan turned out to be wrong. A good answer is honest. I might say that we underestimated traffic during a marketing launch. The system did not fully go down, but latency spiked badly. What mattered was what happened next. We had already defined emergency scaling paths, so we scaled up quickly. Afterward, we updated our planning process to include marketing calendars and ran load tests that reflected burst traffic, not just averages. Showing learning is more important than showing perfection. One more. How do you communicate uncertainty to non-technical stakeholders? Strong candidates explain that they avoid pretending to be certain. I might say that instead of giving a single number, I present ranges and scenarios. For example, best case, expected case, and worst case. I explain what user impact looks like in each scenario and what actions we would take. This builds trust because stakeholders are not surprised when reality lands somewhere inside that range. Now let us move into the technical side. Imagine you are responsible for a web service that sees unpredictable traffic spikes. You have 6 months of metrics, but traffic patterns are noisy. How do you start planning capacity? A strong answer usually starts by breaking the problem down. I would begin by identifying the true bottlenecks in the system rather than scaling everything blindly. That means looking at CPU, memory, request latency, error rates, and downstream dependencies like databases or third-party APIs. I would look at peak usage, not just averages, and pay attention to percentiles. Then I would decide where static headroom makes sense and where dynamic scaling can absorb uncertainty. The plan would evolve over time as we collect better data. Next scenario. You are running Kubernetes, and nodes are frequently close to full CPU during peak hours. Autoscaling exists, but scale-ups are slow. What do? A thoughtful answer does not jump straight to adding nodes. I would first try to understand why scaling is slow. Is it cloud provider limits, node startup time, or scheduling constraints? In parallel, I would consider adding baseline capacity so the system is not always reacting under pressure. That might mean keeping extra nodes warm or adjusting pod requests so scheduling is more efficient. The key is reducing how often the system operates on the edge. Another question. How do you plan capacity for a system that depends heavily on a database? A strong candidate usually shifts focus from compute to contention. I would talk about connection limits, query performance, and replication lag. I would plan capacity by understanding how load translates into database work, not just requests per second. In some cases, scaling the app does nothing if the database is the real constraint. So capacity planning becomes about caching, query optimization, and sometimes architectural changes, not just bigger machines. One more. If leadership asks you for a single number for next quarter capacity, how do you respond? A good answer explains that I would resist giving a single number without context. I might provide a recommended baseline plus a buffer, along with clear assumptions. I would also explain what signals we will monitor weekly to adjust. Capacity planning is not a one-time calculation. It is an ongoing process, and strong candidates make that clear without sounding evasive. Finally, how do you know when you are over-provisioning? Strong candidates usually say that over-provisioning is visible when systems sit far below their efficient operating range, even during peaks. I would mention looking at utilization trends, cost per request, and whether scaling events ever trigger. If nothing ever scales and utilization is consistently low, that is a signal to reduce baseline capacity carefully and observe. The goal is not to squeeze systems to the edge, but to remove obvious waste while staying safe. That is where we will stop for now. Pause here. Think about how you would answer these under real interview pressure. The next part will go deeper into failure modes and hard trade-offs. Let us keep going and push this deeper. You are asked to plan capacity for a system that has strong seasonality. Quiet most of the year, extreme spikes during a few known events. How do you approach this without massively overpaying the rest of the time? A strong answer usually starts by separating baseline capacity from burst capacity. I would identify what the system needs to stay healthy during normal operation and provision that as a steady baseline. Then I would focus on how to handle spikes differently. That might mean pre-scaling shortly before known events, using faster but more expensive resources temporarily, or even relaxing non-critical features during peak load. The trade-off is clear. You pay more during spikes, but you avoid paying that cost all year. The important part is planning those actions in advance so you are not improvising during the event. Next question. How do you plan capacity when downstream dependencies are outside your control? This comes up a lot with third-party APIs or shared internal services. A strong candidate usually says they plan for failure, not just success. I would start by understanding published limits and real observed behavior. Then I would introduce safeguards such as rate limiting, caching, and timeouts so my system degrades gracefully when the dependency slows down. Capacity planning here is not about scaling infinitely. It is about making sure my system does not amplify someone else's problem. That often means intentionally capping throughput to protect overall stability. Another scenario. You are seeing high CPU usage, but adding more compute does not improve throughput. How does that affect your capacity plan? A good answer shows restraint. I would explain that this is a signal that raw capacity is not the real issue. It might be lock contention, garbage collection, inefficient code paths, or I/O bottlenecks. Before increasing capacity, I would profile and measure where time is actually spent. Capacity planning without understanding workload characteristics leads to waste. Sometimes the correct plan is fewer but better optimized resources, not more of the same. Here's a harder one. How do you plan capacity when traffic growth is unpredictable and product cannot give you a forecast? Strong candidates talk about adaptability instead of prediction. I would say that in this case, I focus on reducing the cost of being wrong. That means fast auto-scaling, safe deployment practices, and clear rollback paths. I would also invest in early warning signals that tell us when we are approaching limits, not when we have already crossed them. The goal is not to guess the future perfectly, but to shorten the time between seeing a problem and responding to it. Another question. How do you use load testing when real-world traffic is messy and unpredictable? A thoughtful answer acknowledges the limits of load tests. I would say that load testing is still valuable, but only if it reflects realistic usage patterns. Instead of testing a single steady rate, I would test bursts, uneven traffic, and partial failures. I use load tests to learn where the system bends and where it breaks, not to declare a single safe number. Those results then inform how much buffer I keep in production. Last question in this section: when do you accept risk instead of adding more capacity? This is where maturity shows. A strong candidate might say that not every risk is worth eliminating. I would accept risk when the impact is low, the cost of prevention is high, and recovery is fast. For example, I might tolerate brief latency increases during rare spikes if users recover quickly and there is no data loss. Capacity planning is always a balance. Eliminating all risk usually means spending far more than the business can justify. That concludes this section. If you are answering these questions out loud, notice how often the best answers talk about trade-offs, reversibility, and learning over time. In the final part, we will put you under pressure and see how you make decisions when there is no clearly correct answer. Let us shift gears now. These questions are intentionally uncomfortable. There is no clean answer. I am listening for how you think, not what you choose. First scenario: you are 6 hours away from a major product launch. Traffic projections are uncertain, monitoring looks healthy, but load tests never covered this exact pattern. Do you scale aggressively now or wait and react if things go wrong? A strong answer usually starts by slowing the moment down. I would say that I look at what failure looks like in each option. If I scale aggressively now, I might waste money but reduce the chance of customer impact. If I wait, I save cost but risk slowdowns during a highly visible event. Given the timing, I would likely do a controlled prescale to cover a reasonable worst case, not the absolute maximum. I would also make sure rollback plans and scaling levers are ready. The key is choosing the option that limits irreversible damage. Money can be recovered. Reputation is harder. Next question. Leadership asks you to cut infrastructure costs by 30% this quarter, but you believe the system is already running close to safe limits. How do you respond? A mature answer acknowledges the business reality without blindly agreeing. I would say that I start by validating the numbers and identifying where costs actually come from. Then I would propose options with clear trade-offs. For example, we could reduce redundancy in non-critical paths, accept slower performance during peaks, or delay certain growth initiatives. I would be explicit about the risks tied to each option. If leadership still pushes for cuts that I believe are unsafe, I would document that risk clearly and make it visible. My role is not to block decisions, but to ensure they are informed. Another scenario: you have limited budget to either increase capacity or invest in better auto-scaling and observability. You cannot do both this quarter. Which do you choose? A strong candidate does not rush this. I would say it depends on the failure modes we see today. If we frequently hit limits and recover slowly, improving observability and auto-scaling may reduce incidents more than raw capacity. Better signals help us respond faster and learn. On the other hand, if the system is already well instrumented but simply underpowered, capacity may be the safer short-term choice. Personally, I often lean toward tools that reduce uncertainty over time, even if they do not immediately increase headroom. Here is a harder one. A partial outage happens during peak traffic. Some users are failing, others are fine. Do you shed load aggressively to protect the core system, knowing it will impact more users temporarily? A calm answer focuses on system survival first. I would say that I prioritize keeping the core system alive and consistent. If shedding load prevents a full collapse, I would do it, even though it increases visible failures in the short term. A degraded system that recovers is better than a total outage that takes hours to fix. I would also communicate clearly, so stakeholders understand why this choice was made. The decision is not about perfection, it is about limiting blast radius. Final pressure question. You make a capacity decision based on incomplete data, and it turns out to be wrong. Users are impacted. How do you handle the aftermath? A strong answer shows ownership without defensiveness. I would say that I focus first on recovery and stability. After that, I would be transparent about the decision process, what signals we trusted, and what we missed. The goal is not to justify the mistake, but to extract learning from it. Capacity planning under uncertainty means mistakes will happen. What matters is whether the system and the team get stronger afterward. If you made it this far, take a moment to reflect. Capacity planning under uncertainty is not about finding perfect numbers. It is about making decisions that balance risk, cost, and recovery when the future is unclear. Think back over the questions in this interview. Which one made you pause the longest? Which one felt the most uncomfortable to answer out loud? That discomfort is often where growth happens. If you are preparing for real DevOps, SRE, or platform interviews, practice answering these scenarios verbally, not in your head, out loud. Clarity under pressure is a skill you can train. If this interview was useful, consider subscribing so you do not miss the next one. Each session focuses on a different real-world failure mode and decision space you are likely to face on the job. And if you want to go deeper, drop a comment with the question you found hardest. That feedback helps shape future interviews and discussions.